Okay, in this video we begin to look at Chapter 1, Section 5, which is really all about working with formulas and rewriting formulas. And in this particular exploration, what we're working with here is a parallelogram. A parallelogram, you remember, first of all, has two pair of parallel sides. Second of all, opposite sides are congruent or equal. That means they have the same length. And finally, opposite angles have the same measure. So that's just a little background on parallelograms. The second thing we know about a parallelogram is that its area is base times height, just like with a rectangle. So for example, if I were to cut out this triangle and then move it over, slide it over and place it in this gap here, then I would have a rectangle. It might be a square, but at least it's a rectangle. And so the area of a rectangle is base times height. Sorry, that's the area of a parallelogram is base times height, as is the area of a rectangle. Alright, so once we have that, then we can begin. Now, in this particular diagram, we know that the area is 30 inches squared and that the height is 5 inches, and we don't know what the base is. So if I were to write in to substitute what I do know, I would end up with 30, which is the area, is equal to 5, which is the height, times the base. So we know how to solve for b there. We're simply going to divide both sides by 5, sorry. And we end up with b is equal to 6. Now because b is a line segment, it should not have square units like an area does. So its units of measure will just be inches. So what we want to see here is that with these formulas, oftentimes we have some values and we don't have other values. And that these formulas are made up of many different variables and not just one. Well, what would happen if instead of plugging everything we know at the beginning into the formula, instead we don't plug anything in and we solve for the variable that we're looking for. That means we want to isolate. So in this case, if we don't know what b is, the first thing that we're going to do is solve for b or isolate b. And then we're going to plug in what we know, and we should come up with the same answer there. So if we go back to our area formula, area is base times height, and we want to solve for b, well, we would divide both sides by h. And we would end up with the formula, the base is equal to the area divided by the height for a parallelogram. And at that point, if we were to plug in what we do know, the area is 30 inches squared. The height is 5 inches squared, 5 inches. Then we would end up with 6, and note that inches square on the top cancels with inches on the bottom to leave just inches. So the point of this is to say that when we're working with scientific formulas or geometric formulas, we may have many variables involved. Sometimes we'll know what some of those variables are, and we can plug them in and solve for the missing variable. But we could also solve the formula itself without plugging in any numbers for the missing variable, and then plug in the numbers at the end. And so that's a skill that we want to develop more in this particular section. And I'll go on to the second exploration just as an introduction to this. Okay, so in the second exploration, we're working with, again, a number of shapes here, a number of geometric figures, and we want to be able to talk about the formulas that are referenced for their area, circumference, volume, etc. So the first one, without a whole lot of explanation, we're talking about the area of a trapezoid. You may recall that the area of a trapezoid is 1/2 of the height times the sum of the bases. And we'll go quickly through the other formulas here. So with the circumference of a circle, circumference is 2 times pi times the radius, and sometimes it's also called pi times the diameter, since the diameter is 2 radii, the plural of radius, or radius is half of the diameter. For the volume of a rectangular prism, well, usually we know that as length times width times height, but the length times the width will give us the area of the base. And so often these formulas are given in terms of capital B, which is the area of the base. So if capital B is the area of the base, then this particular shape is just the area of the base. The volume of the rectangular prism is just the area of the base times the height. And for the volume of a cone, similar also, that the area of the base times the height, but for this one we have only 1/3 of the area of the base times the height. Alright, so what we want to do in this particular set of examples is to first solve for the missing variable. That means to isolate that variable, and then to plug in the information that we have and to see what the value of the missing variable is. So we're going to start with the first one. So A is equal to 1/2, just make a little line here so we don't get confused. A is equal to 1/2 of the height times the sum of the bases. And the first thing that I want to do here is to get rid of that 1/2, and I can get rid of a half by multiplying by its reciprocal, which is 2. And so I'm going to multiply both sides by 2, and when I do, I'll tell you what, we'll show that out here. So multiply by 2 and then multiply by 2. When we do that, we're going to get the half, and the times 2 is just 1. That cancels out. We get h times b1 plus b2. At that point, we're going to, and this is letter A, by the way, at that point we're going to divide by the sum of b1 and b2. You have to remember that this is one unit here. We can't divide by b and b1 and divide by b2. We have to divide by the group b1 plus b2. And when we do that, we see we have our final answer here. So we have h is equal to 2 times the area divided by the sum of the bases. Now if we know in this particular case that the area is 63, so we would have 2 times 63, and the bases are 8 and 10, so 8 plus 10, and that would give us 126 over 18, which turns out to be 7. And since this is a linear value, h, it's not an area, it's a length, so we would say that this is centimeters. Alright, so that's the value for A. Let's go on to talk about B then. B, here we have C is equal to 2 pi radius. The missing quantity is the radius, so we're going to isolate the r. We're not going to touch that, and we divide both sides by 2 pi, so that we now have radius is c, the circumference, divided by 2 pi. And in this case we know that c is equal to 24 pi, and we know that the radius, then we know that 2 pi, obviously it's just 2 pi. And when we divide these, the pi's cancel. 24 divided by 2 is 12. The radius is also a line. It's a length. It's not an area. So it should have linear units, 12 feet. And so that does it for part B. Now let's go on to part C. So in part C, we simply had the volume is the area of the base times the height, and we solve that by dividing. The missing quantity here is the height. We're going to solve that by dividing both sides by capital B. And so we end up with the formula H is equal to capital V over B. And capital V in this case, 75 yards squared. Remember, yards squared just means yards, yards. Yards times yards. And the base, no, sorry, it's yards cubed. So it's yards times yards times yards. And the base is 15 yards squared. And so that's 15 times yards times yards times yards. You can notice that 2 of the factors of yards will cancel out, and we'll be left with 5 yards as our height here. Going on to the final example here, we have the volume of a cone. So V is equal to 1/3 capital B H. And what we're going to do first of all here is multiply both sides by 3. And when we do that, we end up with 3V is equal to, and on the right side the 1/3 and the times 3 become 1, cancel each other out, is equal to B, capital BH. The next step would be to solve for the missing quantity, which is H. So we divide both sides by B. And finally we get that H is equal to 3 times capital V over B, and 3 times the volume. 3 times 75 would be 225. The area of the base is 15. And so we end up with 225 divided by 15, which is 15, and our units of measure is yards. So we'll stop this video at this point. You get the idea. We're trying to take these geometric formulas for geometric areas, volumes, circumference, etc. And we may be given a number of values and not have a particular one. So we want to solve using algebraic techniques, that is, those properties of equality that we learn. We want to solve to isolate a particular variable and then to plug in the information we know and to solve. All right, so we'll stop this video at this